Hey there, TouchDesigner developers. Welcome to the first video in what soon will be a series called Another TouchDesigner Tutorial. In this video, we are going to cover how to make a movement technique similar to the arcade game Asteroids in TouchDesigner using only chops. For those of you who are not familiar with the game Asteroids, it was an early arcade game in the 1970s, which featured a triangle-shaped spacecraft in the center of the screen. You could move the spacecraft around and shoot oncoming asteroids, which would kind of move towards the ship over time. We're going to look at recreating that movement method, which allowed you to rotate the ship and move it in the direction that the ship is pointing. So now that you've seen a demonstration of what this network will eventually look like, we can jump into building it. As you can see here, it's actually not quite as complex maybe as you might think it would be. We have a couple of different sections to our chop network and then a pretty simple top network below, which creates the visuals that we see on the screen. So like most tutorials, I'm going to delete everything and start fresh so that we can build this project from the beginning together. So we're going to build the top visual portion of the network first so that we can get that set up, and then we'll talk about the chop portion and the control system that creates this movement technique. So I'm going to start by dropping a circle top down. We're going to use the circle top to create the triangle that will represent our spaceship from Asteroids. I'm going to set my output resolution first to 1280 by 1280. We'll stick with that resolution because it will allow anyone who doesn't have a commercial TouchDesigner license to also follow this technique. Of course, you could make the resolution as high as you want, but we're going to use 1280 by 1280 for this example. From there, you can actually, within the circle top, use this polygon parameter here to output a variety of multi-sided polygons. And of course, we're looking for a triangle, so we can leave the side parameter at 3. We're going to have to do a couple more modifications because right now our ship is actually taking up a majority of our screen. And so I'm going to reduce the radius here to 0.01 for both the X and the Y radius parameters. And from there, if we display this in our background, you can see now we have a very small little triangle at the center of our screen. So now that we have the circle set up, the way that I was able to achieve that color shifting effect was by compositing it with a noise top. And go ahead and grab our noise top. The noise top is often used for creating these kind of color shifting effects by turning off this monochrome mode, outputting a color noise, and then using some of the transformation functions to kind of allow us to animate through that noise. I'm actually going to leave the resolution here at 256 by 256 to kind of reduce the performance lag that can happen on slower computers like mine when you start to output noise at a higher resolution, and then eventually we're going to be running it into a feedback loop, which again is somewhat processor intensive for computers without graphics cards or old graphics cards like what I'm using here. So I'm going to start with the noise page of parameters, which is the first one here, and we are going to first change this period value to 50 so we get more of a gradient across our screen instead of that default noise look. And then I'm going to turn the monochrome setting off so that we get a color gradient instead of a grayscale gradient. From there, we can come to the transform page and add a absolute time dot seconds expression to our Z translate here. And as you can see, it's animating our noise here rather quickly. So we actually want to slow that down quite a bit by multiplying it by a value of 0.03, which will give us a much more gradual change of our color. From there, we can composite these two together so that this color can be applied to our little triangle ship. And I'm actually going to do something here to allow us to make sure that we're using that 1280 by 1280 resolution of our circle top, that we want to keep consistent throughout our TouchDesigner network. So if we change on our transform parameters page the fixed layer here to input number 1, it will actually use the resolution settings from this first input to apply to our final output from this composite. In its current default state, if we middle mouse click, you can see the size here is set to 256 by 256, and that's because it's looking to the second input for the resolution value. So we're going to switch that to input 1, and then if we middle mouse click, you can see that now we are getting a 1280 by 1280 output resolution. From there, I'm going to use a level top to bump the brightness up. I found that adding this level top and bumping the brightness up kind of helped the final effect look a little bit better. So all that we're doing with this level top here, and turn this display flag back off, all we're doing with our level top is changing this brightness 1 value on the pre-page to number 2, and that will brighten up the output from our little ship graphic that we've created. From here, I'm going to place down a transform top, which we're actually not going to do a whole lot with yet. This is where, when we set up our chop network, I'm going to apply the position transformation of our spaceship. And that's going to be done via the translate values here, which allow you to translate things in the X and Y direction. One thing that I am going to do here, though, is modify the scale parameters. Because in asteroids, our ship is actually not a kind of equilateral triangle, but I guess it would be like an isosceles triangle. And having side lengths that are not all equal allows us to kind of see better which direction this is pointing in. And as we're going to be calculating a rotate value, because that's a kind of part of the movement functionality of asteroids, we kind of want to be able to see which direction we're going to be moving in. So I'm going to bump the scale value up for the X direction to 2, and that'll kind of elongate our triangle a little bit. So as I mentioned before, we are going to be applying chop references to both the translate and the rotate parameters once we set up that chop network a little bit later on. From here, we are going to get prepped to set up our feedback loop, which gives us the kind of trailing effect that the original version had. So I'm going to start by dropping a null down to just kind of designate that this portion of our network is complete, and from there we'll drop down a feedback top. We're going to create a pretty simple little feedback loop here to create that trailing effect. I'm going to then drop down a blur and then a level. And finally, I will add a null to the end. For those of you that don't know, Alt-N on your keyboard, PC or Mac, should allow you to drop down a null operator without having to open up the operator create dialog window. From there, we can put a composite down and then make sure to connect this original null here to that composite so that our feedback loop is kind of complete. We, however, are not going to be getting any feedback yet because we don't have a target top referenced inside of our feedback top. So if you drag the comp2 composite top here on top of the feedback top, it will make that reference for you. You could also, of course, drag the composite 2 top into the parameter window on top of this target top parameter. It would do the same thing. So now this is generating feedback, but because our blend mode in this composite is not set to the right operation, we actually don't see anything. So what I'm going to do here is turn this to the, let me check my notes, over mode. A lot of times we'll use the add mode for feedback, but I found that the over mode actually works pretty well for this example. And so now if we were to start moving our ship around by just kind of moving our center point, you can see that we're getting a kind of residual feedback trail of the position. And because I'm moving it at such a high value, it's kind of skipping along the screen here. But if I was to use a smaller increment, you can see that we get a trail behind our ship. And so we are going to make some modifications, though, in this feedback network before we continue, because it doesn't quite look like our original. So I found that by adding a less aggressive blur here, you can get a kind of smoother, a slightly smoothed out trail, but it won't have this kind of effect where it blooms around the ship. So I'm going to come to my blur top here and change this filter size to 2. And then we will change the sample step to 0.05 for both parameters. And then if we were to reset our feedback from here, now we can see that it doesn't create that big blooming blur effect around our ship. We are going to use the level top here to kind of attenuate the feedback as it continues on in a loop, and that'll allow it to kind of fade out over time. So we are going to set that to have an output opacity value of 0.99, and that'll allow it to slowly fade out as it's moving around the screen. Now, one thing that we do have to do before we finish up with this feedback loop is, as you can see here, actually let me move this around a little bit more slowly. Even though this fades out, it never completely fades to kind of a 0 value in our color channels. We still have like this residual transparent layer in our feedback loop, which actually has to do with the pixel format of our output, or our input rather, to this feedback network. And so if we change the pixel format of our circle top here to 16-bit, you can see now the feedback fades out and we don't have, if I move this around again, that residual trail. It will completely fade to nothing now. And that is basically because the pixel format is almost like the resolution of the colors that TouchDesigner can represent, and it kind of defaults to this 8-bit mode, probably for performance reasons. But in certain situations, like with this feedback loop, we want to up that to a higher bit depth so that we can represent more colors and so that our feedback can actually fade to 0 without any kind of residual leftovers from the movement. I'm also going to set up a keyboard in chop here so that we can reset our feedback at any time that we want to. That'll become more useful, I suppose, when we are actually moving this thing around on the screen. So I'm just going to use the 1 key because we won't be using that in the control system that we're going to be setting up. And then I'm going to make a chop reference to the reset parameter of that feedback top. From there, we can composite in a background and our actual top portion of this network will be complete. So I'm just going to use a technique that we've seen in other videos by Electronaut and Paqueta 12, which allows you to use the transform top to quickly composite a background in. My original had a kind of gray color for the background, so I'm going to set the background color here to 0.4 for the RG and B values, and then 1 for the alpha channel. And then if we switch on this comp over background color switch, we now have a background, which we can't see because we were displaying the wrong operator. So now we've got the kind of visual component complete, and we can follow that up with a null and then an out top, so that if we were to use our performance mode, we could see it on screen. All right, so now that we've got this set up, we can actually work on the chop portion of the network, which is a little bit more complex. So we're actually going to start with a keyboard in chop. And as most of us know who've used TouchDesigner, this allows us to take a key input from the keyboard. You can specify a specific key that you're looking for, and it will output a chop value when you have pressed that key down, and it will fall back to 0 as soon as you let go of the key. We're going to use this to create our control system for positioning our little spaceship here, and I have a keyboard with a numpad, so I'm going to set it up to use number keys, but if you have a laptop, you can use a different set of keys, which I'll talk about in a second. So if you have a numpad on your computer, we're going to look for the keys 4, 6, and 8. So you're going to want to type in the numbers of the keys that you're looking for and put a space in between them so that it will grab all of those keys independently from one another. Great, so we've got that set up for those specific keys. If you're on a laptop and you don't have a numpad, you could set this up using the 2 Q and E keys. And the 2 key will be kind of like your up arrow, the Q key would be like your left arrow, and the E key would be like your right arrow. These Q and E keys are also, I believe, by default not connected to anything in TouchDesigner, so it allows you to be in this kind of network editor view and not have certain things happen. There are certain keys in Touch, like the P key, for example, that turns this parameter window off, or the arrow keys will actually move back and forth the timeline at the bottom. We don't want that kind of stuff to happen as we're trying to test this, so I would recommend you use these keys if you're on a laptop. From there, we are going to start to create first the rotation value that we will eventually be applying to our asteroids ship below. And the way that we're going to set this up is the left and the right keys, which in my case are the 4 and the 6 keys, are going to rotate the ship left and right. And then the up arrow, which is the 8 key, could be the 2 key if you're on a laptop, will be used to move the ship in the direction that it's pointing. So if we want to create that rotation, we have to actually use a select chop to select the specific channels, or the specific keys in this case, that we are going to be using to create that rotation. And so what I'm going to do here is type in, well, you could do it 2 ways. You could type in K4 and K6, or you can hit this little drop down arrow here and select from the channels that are currently being input, K4 and K6. And now we can see here that we are only getting the output from those 2 specific operators, or from those 2 specific keys on our keyboard. So now that we've got these 2 keys selected, we are going to use a math chop to actually combine these 2 channels together so we can tell our rotate value whether or not we want to rotate in one direction or the other. We're going to use a math chop to do that. And once you've placed your math chop down, you can hit this combine channels parameter here and use the subtract mode. And that will combine those 2 channels together and give us a value of 1 when we hit the 4 key and -1 when we hit the 6 key. And because the kind of way that degrees work is that positive degrees will rotate you to the left and negative degrees will rotate you to the right, we actually do want our left key, which is the 4 key in my case, to give us a positive value and our right key to give us a negative value. One thing that I am going to do before we move on is within this select chop, we can actually rename our chop channels. And because we're going to be merging these channels and actually basically losing the name of this channel from the 6 key, all I'm going to do here is rename one of the channels, the first channel, to rotate so that we know that this, we know that this channel is for rotation. So you want to do that in the rename to section and not the rename from section. So now it's renamed that K4 channel to rotate, and then because they're being merged, we are just losing that K6 label, and now we have a single channel that gives us our rotation values depending on which button we press. From there, we're going to hook up a speed chop, and the speed chop allows us to kind of count upwards or downwards depending on its input, and in this case it's going to count up or down based on the values that come out of this math chop from our keyboard. So I'm going to place that down, and you can see what will happen here is when I hit my 4 key, it climbs up in number values, and when I hit my 6 key, it decreases in number values. And I found actually after testing this that this amount of rotation is a little bit quick. It's a little bit fast, a fast amount of rotation for our ship. It kind of rotates it too quickly, so we're actually going to change one more parameter on our math chop before we continue, and we're just going to use the multiply value here to attenuate that output. We're going to set it to 0.5, and when we do that, now the output of our math chop will have values of positive 0.5 and negative 0.5, which will in turn move this speed chop's value up and down more slowly. From there, I am going to set up another math chop, which is going to convert this value into degrees. Remember that degrees for rotation have a normal range of 0 to 360 for a kind of complete rotation on your screen. And so if we were using this kind of default setting coming from our speed chop, it would take us forever to kind of make any kind of perceivable rotation happen. So we need to take this value that's coming out of the speed chop and multiply it so that it gives us a larger range of values when we move up and down with our speed chop. So if you come inside of your math chop here and set the multiply value to 360, that's kind of like an arbitrary value that I've selected, but that allows us to have a larger value output from this chop channel that will actually give us more of a visible rotation. You could try different values if you think that that is still too much, but I found that works pretty well for our purposes. So we can hook up a null here, and this is kind of the final step of the rotation portion of this network. So after a quick technical difficulty here, we have actually completed the rotation portion of our network. And so I'm going to rename this null to rotate null, just so that we know that that is where our rotation value is coming from. And then we can actually make a chop reference to our transform below. So again, if you haven't done this before, hit the viewer active button and click and drag from the center of that chop over to the parameter in your parameter window you want to apply the reference to and hit chop reference. You also have to make sure that you've clicked on the operator that you were trying to apply the chop reference to before you try and drag, otherwise it won't have that open and you won't be able to apply it correctly. So now if we look at our final output here and I hit the 4 and the 6 keys, you'll see that it will rotate on my screen, but it's not doing it correctly. It's like rotating around a center point instead of having our ship kind of rotate around the center of the ship. So the reason why our ship here is rotating in a circle around a center point instead of kind of around its own center point is because I accidentally left the center position here at 0.015 instead of at 0. So if we set that back to 0, now our rotation should work the way that we intended it to. So we've successfully set up the rotation value for our spacecraft, and we now need to work on calculating its position. This is where things start to get a little bit more complicated. First, though, we are going to create a simple on-off switch portion of our network here that will tell our ship when we want it to move. So when we're hitting the 8 key on the keyboard in the instance of my version of the sketch here, that will tell the functionality that's going to move the ship that it's time to move the ship. So I need to start by creating a second branch of this keyboard in chop network by middle mouse clicking on the output of that keyboard in chop and dropping down a select chop. And I need to select the K8 channel in order to isolate that 8 key. I'm going to rename this chop channel to Excel, meaning that we want the ship to accelerate when this key on our keyboard is pressed. From there, I'm going to hook up a math chop. I found that since this will effectively control the rate at which our spacecraft is moving on the screen, a higher number will essentially make it move more quickly across the screen. And I found that by using a math chop to attenuate this value, we can get a speed that is a little bit more useful. It's fast enough, but not too fast. So if we drop the math chop down here and then multiply it by 0.5, I found that that gives us a value that looks a little bit better. And what that means in terms of our chop channels is that now when I hit the 8 key on my keyboard, I get a value of 0.5 when I've pressed it down. From there, I can attach a null, and then we can start looking at how we can take these two pieces of information, this rotation value and this acceleration channel, combine those together and start calculating the position for the y and the x direction. We actually have to do this with a little bit of trigonometry. Trigonometry has a variety of useful functions for calculating the position and angle of different things, and we can actually use these basic trig functions that come from calculating the sides of a right triangle. When you know either the angle, hypotenuse value, or one of the sides, you can start to calculate different components that are unknown. We can take these formulas and actually apply them to our situation here and get the velocity in either the y or the x direction, and that's basically what we have to do. If we want to be able to calculate the position in either of those directions, we first have to calculate the velocity, and then we can use the speed chop to convert that speed value or the velocity value into an actual position. So we can take a look at these basic functions here, walk through those, and then talk about how those are going to be applied using our values from our chop network. So you can see here that we have, these are the two basic trig functions. And what they're referencing is that if you have the sine, or if you calculate rather the sine of this theta angle, which again in terms of our TouchDesigner sketch would be this rotation angle, that is equal to the opposite side of this triangle divided by the hypotenuse of the triangle. And basically the opposite and adjacent sides are the two sides that are making up this right angle, and the hypotenuse is the side that is opposite of that right angle. So we actually know the hypotenuse of our particular triangle. That is our acceleration chop channel here. Remember that we set this up so that we can tell our ship when we want it to start moving. So we know this value, we know the rotation angle, so we can actually use those to calculate the y velocity and the x velocity. So if we want to isolate this opposite side and therefore calculate its value, we can multiply both sides of this equation by the hypotenuse variable, and then we get the final form of the equation that we're going to recreate using chops, which is the hypotenuse length, which remember again is the velocity value from our 8 key, and then multiply that by the sine of the current angle, and that will give us the y velocity value. So this bottom function here, I've just replaced these generic triangle side names with our actual TouchDesigner components that we're going to be calculating. So the acceleration, this actually should say velocity value, not acceleration. The velocity value, which is coming from this K8 key, and then multiplied by the sine of our rotation angle will give us that y velocity value. Then if we wanted to calculate the x velocity value, we would do the same thing. In this case, it's the cosine of theta equals the adjacent side, and adjacent side is in reference to this angle. It's the side that's connected to it. The opposite side meant that it was opposite from this angle that we're using in our calculation. So the adjacent side divided by the hypotenuse equals cosine of that degree, or that number of degrees that make up this angle. So if we do the same thing where we multiply both sides by the hypotenuse, we can get our final form of the equation. Again, this acceleration value here should say velocity times the cosine of theta will equal our x velocity value. So great, we have these kind of theoretical formulas. How can we actually apply this to our TouchDesigner network? Well, let's take a look. The first thing that we're going to have to do is we're going to have to make essentially two different branches of our network that both stem from this rotate null, so that we can calculate the final x position and the final y position. So what I'm going to do is I'm going to build it one branch at a time. We'll build the y position branch first, and then we will copy and paste that for the X branch, just so you don't have to place down twice as many operators. So I'm going to first drop down the function chop, and the function chop has a variety of mathematical functions within it that you can apply to the particular chop channel. If we look back at our reference again, to calculate our y velocity, we're going to have to take the sine of our rotate angle. And so if we come to the function parameter here, we can click on this sine function here. Note that there is a sine function and a sine function, which both sound the same, but you want the one that's spelled S-I-N-E and not S-I-G-N. So again, it's the fifth option in that list. So that will calculate the sine of that rotation value. And then we're going to use a math chop to allow us to multiply, again, this should have said velocity, multiply our velocity value by that sine of theta that we've just created. And I might even, I might change the name of this now so that we don't get confused. We'll just call this move. That's a trigger that's telling it our spaceship that it's time to move. So that will make it less confusing, hopefully, for us. So we need to multiply that move value again by the sine of theta to get that final y velocity value. So I will drop down a math chop, and then we can move this null a little bit over and connect it to that math chop. And then we can come into the parameter window for the math chop, and we want to combine these two chops together. So we want to use this combine chops parameter, set that to multiply, and that will multiply the values within those two chop channels together. From there, we want to actually take this velocity value that we've just calculated and enter it into our speed chop. So remember that our speed chop, if we look at the definition along the bottom, converts speed to distance over a period of time. So you can give it a rate and it will output a cumulative value. So it's taking our velocity value and it's converting it to distance, which in terms of our project here is giving us our final position value. So again, we're going to take that speed chop and connect it to the output of this math chop, and then that will actually calculate our final position of our spacecraft. And from there, I'm going to drop down a rename chop because I want to rename this chop channel to something more logical than rotate. Rotate isn't super helpful anymore because we now have separate positions for the X and Y, and so it'd be kind of confusing if they both had the same channel name. So I'm going to rename this to Y position, and then I'm going to drop a null down at the end, and that branch is essentially complete, so we can select all of that, copy it and paste it, and modify it slightly to get our X position. So the first thing that we need to do, if we come back to our diagram, in terms of calculating the X velocity value, we have to do the cosine of theta instead of the sine of theta. So all I have to do within my function chop here is change this function parameter to cosine, which is right above the sine value. And then from there, everything is the same up until this rename chop. We need to change this to say X position. And then for the sake of clarity, I'm going to merge these chop channels into a single chop and then add a null at the end and rename that position null so that we know this is where we should be grabbing our final position from. So we are going to have to make a couple of modifications in a second here, but essentially our positioning network that will allow us to move this thing around is complete. So we can make that chop reference from this position null now. So I'm going to just drag the Y position channel over to the Y translate value and then the X position over to the X translate value. So now if I started trying to move my spaceship around, you can see it rotates and it also moves a little bit maybe too quickly for my taste, but it is functioning. And one of the problems, though, that we're going to run into is that if we move the ship off screen, it will just kind of infinitely go in any direction. There's no limitations on the position yet, so we can basically get lost in this invisible space off of our screen. Fortunately, the speed chop, which again is the thing that's calculating the position of the ship, has a built-in limiting function which can allow us to set a range of values within which that position will fall. So if we select both of our speed chops at the same time, we can turn that on by coming to this limit type parameter and hitting clamp. So the other thing we have to know as we are limiting our position is the range of values that we want to limit it between. So we set a minimum and a maximum value that will limit the position of the X and the Y channels respectively. And the way that positioning works for a lot of things in TouchDesigner when you're using the typical fractional positioning modes is the center of the screen is 0.00, and then the fractional modes will give you a maximum value approximately of 0.5 for that center point, and then negative 0.5 on the left. So if you had a rectangle in the middle of the screen, you move the X position to 0.5, the center point would be right at the edge on the right side of the screen, and vice versa. If you put it to negative 0.5, the center point would be right at the left edge. So we usually want to limit our boundaries within that range of approximately negative 0.5 to positive 0.5. And then what will happen is our ship, when we hit the edge of the screen, it will just stop instead of continuing on infinitely and being hard to locate again. This is cool, but this actually is not how the original Asteroids game functions. In the original Asteroids game, the ship is allowed to continue beyond the edge of the screen, but whenever you pass any edge of the screen, it will loop around and show up on the opposite edge of the screen in a short amount of time. And so we can actually recreate that same functionality with the speed chop again. One thing that I am going to do, I think, before I do that is I'm realizing from my notes that my math chop here that sets the speed of our little spacecraft was actually set to 0.25, which gives us a slower but more manageable speed to our spaceship. So if you want to change that now, go ahead. So anyways, as I was saying with the speed chop, the limiting functionality actually has a mode that would allow us to loop the position once we hit this edge and have it show up on the opposite side. And that is if we set the limit type to loop. So what will happen now is if we get close to the edge, you'll see that once we hit the edge, it showed up on the other side of the screen and allows us to keep looping around our screen space regardless of which edge we're going off of. Now there's one sort of issue with this technique right now, and that is it starts to, or rather it resets the position to the opposite side of the screen before the spaceship disappears. And that's actually a little bit different from how it used to function in the original game. So what we can do is set a sort of buffer zone off screen, give ourselves a little bit of space so that the spaceship can completely disappear off screen and then reappear instead of being reset before it's even off the edge of the screen. And all we have to do to make that happen is set the limits a little bit larger than they are here. I'm going to set them both to negative 0.55 for the minimum and the maximum of 0.55, and then you'll see the spaceship completely disappears and then reappears on the other side. Also note that my output is looking pretty choppy because my graphics card is a little bit old and can't really handle it, but when I'm in this perform mode, I get a much smoother output. So there's a couple other things we can do. Even though we're technically done with recreating that technique, there are a couple of small tweaks that the original had, which made it even more interesting to interact with. And the main thing that we can see right away is that when our ship, when we let go of the up arrow, our ship immediately stops. There's no inertia at all. There's no kind of physics applied to the ship. And the way that we can actually implement that is with the filter chop. So you might think, okay, I can just attach a filter chop maybe to the position values and get something in the ballpark of that inertia effect. And you'd be somewhat right. It does allow you to have a bit of inertia-like values, but you'll see what happens here is it starts to do this kind of fishtailing as it turns instead of just the traditional rotation that we had before. So that's kind of a cool effect, but not exactly what we were going for if we want to recreate that asteroids movement. Um, so we're going to actually look at how you can actually approach this a little bit differently and get a result that looks even closer. You can actually add the filter chop into this movement channel that we set up here, this movement switch, so that it gives it a little bit of inertia. And what that's basically doing, so I'll demonstrate it first. Started moving, and now I've let go of the key, and you can see it continues moving for a second after I let go. So it's adding a filter to this data so that it doesn't just immediately go from 0 to 0.25 and from 0.25 to 0. There's a little bit of a smoothed transition between those two variables. So you can increase the filter width here to increase the amount of time that it takes from it to get to full speed and then to get from full speed back to 0. So you can see here it takes a little bit of time before it gets up to speed, and then when I let go, it will move on or continue moving for a while after that. So that is it for this tutorial. I hope that was helpful in taking that technique and learning how you can use chops to recreate it. I thought this would be a good example to see how we can work with chops to build that sort of functionality, an interesting use case to see what's possible in the world of chops as you're starting to learn how to use them. Remember that this is going to be the first in a series of videos that I'm going to be making about TouchDesigner and a variety of different applications for TouchDesigner. So make sure to like and subscribe and stay tuned for more videos. They will be coming soon, and I look forward to seeing you guys in the next video.